So identify whether these compounds are likely to contain an ethyl isopropyl or T-butyl group. The red numbers tell us the number of protons. So we want to look at the number of peaks. There are 7 peaks here and 2 peaks here. So a 7,2 means that it's an isopropyl. So your isopropyl group is going to look like this. Your 6 green protons are being split by the 1 orange proton, and your 1 orange proton is being split into 7 peaks by the 6 green protons. So let's look at the next one. Here we've got 7 peaks, 4 peaks, a doublet, and a triplet, 3 peaks. So we already know that when we have 7 peaks and 2 peaks, 7 peaks and 2 peaks, that indicates an isopropyl. The 4 peaks and 3 peaks indicates an ethyl. So here I've drawn the 2 structures, and I've tried to color code which peaks are coming from which protons. So the ethyl group is this orange and pink molecule right over here. The orange, the 2 protons are being split into 4 peaks, and we end up with orange right here. The pink protons there are 3 of them, and they're being divided into a triplet, and that appears here. The blue ones are part of the isopropyl group, and they are here. And that purple one is down here. So if we look at this, and we look at our integration values, 6 is the lowest number. We divide everything by 6. We divide 55 by 6, we're going to get 9.1. So there are 9 protons here, and it's a singlet. So that indicates that we have a tert-butyl. So we have 9 protons that are completely isolated, and so we get this nice singlet. This last one has 5, 2, 2, and 1. That does not fit any of the patterns that we talked about. There can be complex splitting. A proton may have 2 different neighbors. It may have a neighbor on the right and a neighbor on the left. And you'll end up with things like quartet of triplets or triplets of quartets. Needless to say, this becomes very complex, and probably we won't be asked to look at any of compounds with these structures. There are some protons that lack coupling constants. These are compounds that aren't going to show multiplicity, and two of the most important are going to be that hydroxyl proton. It's going to be involved in hydrogen bonding with water, and so it's not going to be, it's going to have a blurred signal. You're not going to be able to see splitting with that. The other thing you're not going to see splitting with is an aldehydic proton. So if you've got an aldehyde here, this proton right here will couple very weakly with its neighbors and appear as a singlet.